After gas, now we will learn about liquid. Our learning outcome is discussing the properties of liquids, explaining vaporization and condensation process, define vapor pressure and boiling point, and explaining the boiling process. There are 5 properties of liquid: volume and shape, diffusion, viscosity, surface tension, and compressibility. Number 1. Volume and shape. Liquid has no definite shape. It takes the shape of the container. The intermolecular forces are not strong enough to hold the particles rigidly in place, and molecules can slide past each other. Thus, a liquid flows to fit the shape of its container. Number 2. Compressibility. Liquid is incompressible. The molecules are packed closely together, and there are very little empty spaces. Number 3. Diffusion. Liquid can flow readily but slower than gas. Liquid molecules are arranged more closely than gas. It has lower kinetic energy than gas and stronger intermolecular attractive force. Number 4. Surface tension. Molecules within a liquid are pulled by intermolecular forces equally in all directions. However, molecules at the surface are pulled downwards and sideways by other molecules, but not upwards away from the surface. These unbalance intermolecular forces. Each molecules are pulled into the liquid and cause the surface to tighten like an elastic field. The stronger the intermolecular forces, the higher the surface tension. Why? A water strider can walk on water. Water strider can walk on water because the surface tightens like an elastic field. Number 5. Viscosity. Viscosity is a measure of the liquid's resistance to flow. The greater the viscosity, the slower it flows. The bigger size or higher molecular mass and stronger intermolecular forces will higher viscosity, but at high temperature, the viscosity will decrease. Vaporization. Vaporization is a process in which liquid is transformed into gas. It occurs in 2 ways: evaporation, and boiling. Based on kinetic molecular theory, molecules in liquid move quite freely. Each molecule possesses different magnitude of kinetic energy. When the kinetic energy is sufficient enough to overcome the attractive forces that bind them, the molecules will loosen themselves and be evaporated off. There are three factors affecting vaporization rates: surface area, temperature, and intermolecular attraction forces. Surface area. The larger the surface area, chances for the molecules to escape from the water surface increases. So, evaporation rates will increases. Temperature. At higher temperature, more molecules possess higher kinetic energy. More molecules have enough energy to escape from the surface of the liquids. Thus, evaporation rates will increases. Intermolecular attraction forces. The weaker intermolecular attraction forces, the faster the evaporation rates. Condensation process. This process, which gas is transformed into liquids. Based on kinetic molecular theory, some of vapor molecules may lose their kinetic energy during the collision. They do not have enough energy to remain as vapor molecules. They reach the surface of the liquids and became trapped by the attractive forces. If they cannot overcome the attractive forces, these vapor molecules return as liquid molecules. And this process known as condensation. Vapor pressure. The pressure exerted by vapor in equilibrium with its liquid in a closed container. In an open system, vapor molecules which evaporated off will diffuse away, while in a closed system, vapor molecules which leaves the surface cannot escape from the system. Boiling point. Boiling point is the temperature at which vapor pressure of liquid equal to the external atmospheric pressure. This process of changes from liquid to gases occur at the surface and in the bath of the liquid. In this process, the bubbles are observed. Temperature remains constant during the boiling process. Even heat is supplied. It occurs at specific temperature and specific pressure. Vapor bubbles form within the bulk of the liquid. It rises to the surface and escapes. The pressure exerted by escaping molecules equals that exerted by molecules of the atmosphere.